Okay, so this is topic 1, motion in a circle. We're describing the motion of an object that is circular. So we have this car that we've got a picture down there. If we say that it's going around in a circle, okay, it's got a certain velocity. In this case it's 30 meters per second. And as it goes around, we're keeping the same speed, so the magnitude is unchanging at all times. Now, with reference to a definition, is the car going at a constant velocity? Well, the definition of velocity is change of displacement over time. So displacement depends on direction. Okay, so it's a vector, depends on direction. So because the magnitude is staying the same, but the direction is changing, it must be undergoing some sort of change in velocity. So definition is from velocity. Okay, it includes direction, so it must be a change in velocity. With reference to a formula to discuss the acceleration, so because acceleration is equal to change of velocity over time, that is not equal to 0, so in that case there must be acceleration. With reference to a formula to discuss the forces involved, because of this formula F equals ma, this one here is also being non-zero, then there must be a force. Now, which direction is this force? Okay, well, if you look at it here, this thing's going around, and as you go around, the size of the magnitude is unchanging. Okay, so to actually change the direction, you need to apply a force. Now, the force in this case must be 90 degrees to that velocity vector, because otherwise you would, if you had, let's say, a force heading off this way, then this component of the force would actually go to extend that magnitude. Okay, but because we are only looking at changing the direction, the force is that direction. And because of that, acceleration is always the same direction. So the force is actually always towards the center of the circle, and so is the acceleration. And that's why we call it the centripetal force. So we consider two objects on a turntable. They both travel from A to B, same for each, and what is different? Okay, what's the same for each is the time for travel. Okay, they both travel the same time, and they both travel the same angle. Okay, what's different is the velocity. Okay, we have velocity 1, velocity 2, and velocity 2 is much greater than velocity 1 because it's covered a larger displacement in the same time. So because of that, we have two ways of explaining stuff going in circular motion. We have angular velocity and also linear velocity. So going around a circle, as you rotate around, okay, the displacement is essentially the distance, straight line. Remember, displacement is always a straight line distance between 2 points. So between there and there is your displacement. Okay, sorry, that was S for arc. Whereas angular displacement is effectively just what angle you've gone around, and it's always in radians. Difference between linear and angular velocity. Okay, the linear is always the tangent to the point, no matter where you are. Okay, it could be in there, so always a tangent. So, however, angular velocity is how far you've swept an angle in a certain amount of time. Okay, so if we had the object here, let's change colour. Let's say we had the object here, and we released it, it will head off with a linear velocity which can be given by displacement over time. Or you could think about it covers this much displacement, which is the circumference, 2 pi r, in a time of t. Okay, and so that will be a linear velocity. However, angular velocity, omega, is equal to delta theta over t, okay, where it's the change in angle per second, okay, so it's in radians per second. And that's essentially what this talks about, okay, so you're putting in the formula omega equals delta theta over t, okay, and it's measured in radians per second. If you look here, the time period for one rotation, t is equal to distance over velocity. 2 pi r is the total distance around divided by the velocity, which equals 2 pi over omega.